Assalamu alaikum. Hope that everyone is well. Welcome to the fourth online class of Maths, Unit 2, Theory of Quadratic Equations. And the topics are nature of the roots of a quadratic equation and cube roots of unity and their properties. Let's have a quick revision of the previous topic, nature of the roots of a quadratic equation. As it was discussed in the previous lesson, that when the standard form of quadratic equation is solved by completing square method, then as a result we will have two roots, minus b plus minus b square minus 4ac divided by 2a, which is basically named as quadratic formula. Then it was discussed that nature of roots depend on the value of the expression b square minus 4ac, which is called the discriminant of the quadratic equation. In short, we can say here that if we are interested to find the types of the roots of the quadratic equation, then it can be found with the help of this discriminant, even without solving the quadratic equations. Let's see how this statement is justified ahead. Here are some statements which will help us to justify this statement that nature of roots depend on the discriminant. If b square minus 4ac is greater than 0 and is perfect square, then the roots are rational, real and unequal. Here we can see in the example that the discriminant is greater than 0 and is perfect square, therefore the roots are rational, means they can be written in fraction form, and unequal due to plus and minus sign, because plus will have different result and minus will have different result. If we see second one, if discriminant is greater than 0 and is not perfect square, as 5 is not perfect square, then the roots are irrational and unequal. It will be irrational due to this non-terminating and non-recurring radical of 5. If discriminant is equal to 0, then the roots are rational, real and equal. This is the only case where the roots will be equal, and this is because of that discriminant is 0. If you add or subtract 0, so it will not affect the result. So hence we will have equal roots, and the roots are rational. Why? Because minus 2 can be written in fraction form. The last one is that if discriminant is less than 0, means negative number, then the roots are imaginary. As we know that the negative sign or inside the square root is written, and negative does not have square root. So therefore the square root of minus is imagined as iota. So hence the result is imaginary. Here we can conclude that nature of the roots depend on the discriminant. Here we have exercise 2.1, which consists of 10 questions. The 5 questions we have done in the previous lesson, in the previous class, and the rest will be done inshallah today. Let's go with question number 6. Find the condition that the roots of the equation are equal. Here we are supposed to find the condition for which the roots of the equation will be equal. Let me tell you here one thing, that whenever you see the information related to the roots, it means you can link it with the discriminant, because the roots depend on the discriminant. So if the roots are equal, so the discriminant will be what? Of course the discriminant will be 0. Let's go with this question. Here we can see that the equation is written. First of all, we have to verify that whether the equation is written in standard form or not. Here we can see that this is not written in standard form, so we have to convert it. mx plus c whole square, it means that this can be a formula of a plus b whole square. So this is a square, this is 2ab, and this is b square, and 4ax is written as it is. Then here what we have done, 4ax and 2mcx are written side by side, so that we can take x common in order to write this in standard form. This is ax squared, this is bx, this is plus c square, c is equal to 0, the standard form of quadratic equation. Now we can proceed ahead. Here we have to use the information given in the question that the roots are equal. So for equal roots, discriminant will be 0. You cannot write here 0 until and unless you write this statement. So this is very, very important to be written here. Discriminant b square minus 4a is equal 4ac is equal to 0 here. The value of b is what? 2mc minus 4a, the 4a, okay. Then the value of a is what? M square. The value of c is c square. These have all been substituted here. Then 2mc minus 4ac, it makes a formula of a minus b whole square. So hence this is a square minus 2ab plus b square, and minus 4m square c square is written as it is. 2 2s are 4 m square c square. Then here this all are written. After multiplication, 2 2s are 4, 4 4s are 16. Here like terms have been cancelled and we have the shrink form as a result. Here for further simplification, we can take 16a common. So a is left inside and minus cm is left inside. Again for further simplification, 16a is brought to that side and it is in division because it was being multiplied here. So a minus cm is equal to 0 is the simplified form that we cannot solve ahead, we cannot simplify it ahead. But here we were supposed to find the condition which will make the roots equal 0, and the roots will be equal if discriminant will be 0. So here yet the discriminant is not 0, so we have to find such conditions which will make it 0. So we have to be very thoughtful and very rational here that what should be that condition. So let a is equal to cm be the condition. Why a equals cm? Because if instead of cm I put a, so a minus a will be 0. If instead of cm I put a, so if instead of a I put cm, so cm minus cm will be 0. So hence we have chosen this condition. Instead of a, cm is put, and cm minus cm makes the discriminant 0. So hence we can conclude here that a is equal to cm is the required condition for equal roots. Next question is question number 8, the first part. Show that the roots of the equation are rational. Here in this question we have to prove that the roots are rational. And as we know that the roots can be linked with the discriminant, so for proving that roots are rational, discriminant must be proved perfect square. As we have previously discussed in the statements, that if the discriminant will be perfect square, so the roots will be rational. So here in order to prove the roots rational, we have to prove the discriminant perfect square. Okay, here we have the x equation written, and here we have the discriminant. We can put the values like the value of b is bc minus a, and the value of 4a, the value of a is a into b minus c, and the value of c is what? C into a minus b. Here we can see b square c minus a whole square, so the formula a square minus 2ab plus b square, then 4ac, and brackets have been multiplied with each other, so we have ab b square minus ca and minus b minus plus bc as a result. B is multiplied with the whole bracket here, and 4ac is multiplied with the whole bracket here. Now we can see here that we have some terms which are perfect square, like bc square, ab square, and 4ac square. So they have been arranged here. First ab, then bc, then ac. Then we can see that this term and this term are like, because both of them has a b square c and a b square c, so hence they can be solved. 4 minus 2, the result is 2. Then these terms are written as it is. Here again this expression is written. We can see here that this can be written in whole square form, this can also, and this can also here, and this all are written as it is. As we are supposed to prove it perfect square, we have to prove the discriminant perfect square. So we have 3 perfect square formula, like a plus b whole square, a minus b whole square, and a plus b plus c whole square. Since in this question 3 terms exist, so we have chosen this perfect square formula for this. A plus b plus c whole square equals a square plus b square plus c square plus 2ab plus 2bc plus 2ca, which you have already done in grade 9 if you remember. So here we can see we have to connect this statement with the formula, that whether it will match the formula or not. So here is a square, here is b square, and here is c square. Then 2ab, then 2, this is bc, and this is 2ca. This is c and this is a. So let's check it, that whether it is fulfilling this statement, it matches this statement or not. You can see here this is again the same thing, minus minus plus, again the same thing, 2abc square, the same thing. But here you can see that we have put plus due to formula, but in the expression minus sign exists. It means any of these terms is negative. So we have to be very rational that which of these term is negative. Here of course a, b or bc cannot be negative because this is positive. It means here any term is negative. Since bc is not negative, so of course 2ac is left and it can be negative. So here we can put minus sign with this, and here we can put minus sign. So now if you will check this, 2 minus 4 a, and we can see here that a into a, then b square we can see, and then a b into c square. This one is this one. If we will see 2 2s are 4 minus 4, and this is a square, then bc. It means this should be written first, this should be written, then this should be written. Here arrows are somehow let me correct it. This is the result of this, and this is the result of this one. Okay, here we can shrink the formula ab plus bc plus this is a, this is b, and this is c, and this is whole square, plus minus minus, hence this is a perfect square. So we have proved the discriminant perfect square. So here the roots are rational then. Okay, question number 9 is that for all values of k, prove that the roots are real. We have to prove here that the roots are what? Real. And we know that the roots will be real when the discriminant is greater than 0. If the discriminant will be less than 0, means it will be negative, so the roots will be imaginary. So we have to prove the discriminant greater than 0 or positive. Here we have written the discriminant, the value of b is written. Then for ac, the value of a is 1 and the value of c is, here in your book it is written 3. In old edition it was 3, but when in the new edition this has been rectified and this is 4, so you have to make it 4. Okay, here we can write the value of c4. 4 4s are 16 here, and here we can apply the formula a square plus 2ab plus b square. 16 minus 8 results in minus 8. Here for further simplification 4 is taken common, and we can shrink this formula, this a plus b, a square plus b square minus 2ab, so a minus b whole square. Okay, since we are supposed to make it positive, so what we have done for that, we have make it a perfect square, because every number when it is written in square form, it will be automatically positive. Like if I write even minus 2 raised to the power 2, so it will be plus 4. So therefore when you will write this whole expression in perfect square form, so you can conclude that this expression is greater than 0, and of course it is perfect square. So if it will be perfect square, or if it will be greater than 0, so it will be positive for all values of k. So if it will be positive, the discriminant, so the roots can be real. Here given that here it is given that k should not be equal to 0. Of course, if instead of k you will put 0, so 1 upon 0 will result in undefined or infinity. Next is question number 4. In the previous lesson I told you that we will discuss question number 4 at the end, because it is a little bit different from the other questions of exercise 2.1. As in, what is the difference between this question and the rest? In the rest questions, the discriminant or the roots are directly linked with the discriminant. However, in this question, the information is not given related to the roots. Rather, the information is given related to the expression, that the expression is perfect square. This expression is a perfect square. This question can be solved as we have done in exercise 6.3, where we were supposed to find square root in class 9. But since we are dealing with discriminant, so better to link this question with discriminant. So here we are indirectly giving it link to the discriminant. How? We can write this statement: since the expression is perfect square, so therefore the roots are rational and equal. Let me tell you here that if the expression is perfect square, so the roots will be equal, like x plus 4 whole square. This is a perfect square. So like I can write it for you that x plus 4, if this is a perfect square. So if I write it 2 times, so the roots will be what? X minus 4 and x minus 4. So hence the roots can be equal. So if the roots are equal, so the discriminant can be 0. That for equal roots, the discriminant are 0. So here we can put the discriminant 0. We cannot write here the discriminant equals 0 until and unless you write this statement. So these statements hold great importance. Under B, the value of B is written, then for A, the value of A is what? K, and the value of C is what? 4. So here again the formula is applied, and 4 4s are 16k square. Here we can multiply 4 with all the terms, and here we can see that 16 k minus 4k square results in minus 12k square. Here minus 4 is taken common because the expression starts with minus sign. So for further simplification or for convenience, what we do, we take minus 4 common, then minus 4 when brought to that side will get divided, so we have 0 here. Here we can have three terms. This can be solved either by quadratic formula, or either you can solve it by midterm partition. Here you can take 3k common, here 1 is taken common, both the brackets are same, so we can k can be equal 1, and 3k plus 1, the value of k will be minus 1 upon 3. Okay, here let me tell you here that we were supposed to find such values of k for which the expression be perfect square. So if you put the value of k in this expression, like k1 1 is 1 plus 1 2, 2 2s are 4, so it will be x square plus 4x plus 4. So x square plus 4x plus 4 is a perfect square. So therefore the perfect square, the roots are equal, and if the roots are equal, so discriminant will be 0. So this was question number 4, and here we are done with exercise 2.1. Now we have to go ahead with next topic, cube roots of unity and their properties. This is exercise 2.3. First of all, let's go with the explanation of the topic. Cube roots of unity. Here, according to this topic, unity means 1. And cube roots is taken here. This is a cube root. We can write this in exponential form as well as 1 raised to the power 1 upon 3. Likewise, we have the square roots of unity. We have the cube root of unity. Like if we take the square root of 1, we will have plus minus 1. Why minus as well? Because when we multiply minus 2 times, so it will again result in plus 1. Mostly what we do, we just directly write the square root of unity as 1 plus minus 1, or we just find it with the help of calculator. But we must know that how this answer is brought. So let's go with the derivation of this. Let x be the square roots of unity. Suppose you don't know that what is the square root of 1. So you let it equal x. So let x be the square root of 1. In order to solve this expression, we take square in order to eliminate the square root. So taking square on both sides, here will be square, and here the radical is eliminated, or the square root is eliminated. For further simplification, we bring minus 1 to this side. Here we can have a square minus b square. So formula is applied: a plus b, a minus b. The value of x will be minus 1 and plus 1. So see, this is proved here by solving it properly. Likewise, we have solved the square root of unity. We can solve the cube roots of unity. How? Let's see. Cube roots of unity and their properties. This is the topic. The cube roots of unity. Like suppose we don't know that what will be the roots or the answers of 1 when its cube is taken. So when we don't know the answer, we let it equal x. Let x be the cube root of 1. This is the cube root 1 upon 3, or you can write inside the cube root. Okay, in order to eliminate this exponent, cube is taken on both sides, so x3 into 1. Now 1 has been shifted to this side for further simplification. Here we can see that cube is above both the terms, so we can apply the formula. As you remember, in grade 9 we have done it multiple times. So here we can apply a minus b, a square plus ab plus b square. Here we have two brackets, x minus 1 can be let equal to 0, and this can also be equal to 0. So we can solve this too. X minus 1, x is equal to 1. We can have, this is the real root, as 1 is a real number. As far as this expression is concerned, we have to factorize it, since it cannot be solved by midterm partition, because if we multiply 1 with 1, we can get 1, but 1 plus 1 will not result in 1, rather it will give 2. So therefore, quadratic formula is used in order to solve this expression. Here directly the quadratic formula is applied, and as a result we can see here we have these two roots, minus 1 plus minus 3 divided by 2. As I told you that the square root of minus does not exist, so therefore it is let equal to iota. Okay, here we have the two roots of unity. Minus 1, this has been separated here, plus ones with minus here. Now how many roots, cube roots of unity we have? 3. 1, 2 and 3. 1 is the real root, whereas the other two are known as the imaginary root or complex cube root of unity. Recognize that complex cube or root of unity as omega and omega square. What is done here? As this is a lengthy root, like it takes time to state this root, that minus 1 plus 3 iota divided by 2. So therefore, for convenience, to facilitate oneself, it is given a name as omega and omega square. So these are the complex cube root of unity. You can write this with iota, or you can write this minus 3, that is fine. So if we name any of these as omega, pronounced as omega, and the other is omega square. One can be named as omega and the other can be omega square. Why omega square? It can be proved in the next article. Let's see how. Properties of the cube roots of unity. Prove that each of the complex cube root of unity is the square of the other, as one was omega and the other is omega square. So we have to prove that these are the square of the other. How? Like these are the two complex cube roots of unity. Here it is written, one of them minus 1 plus 3 divided by 2. If you go with squaring of them, if you take the square of these, so the result will be the other roots of the other root of that cube root. Let's go with the squaring. Like if we take the square, so you can see here minus 1 plus radical minus 3 whole square. It makes a formula of a plus b whole square. So a square, this is done directly here, a square, this is b square, and this is 2ab, and 2 2's are 4 here. Here it has been simplified and 2 is taken common here. Here you can see 2 1 is 2, 2 2's are 4, and minus 1 minus 3 iota divided by 2. You can see that when the first complex cube root of unity is squared, so it has resulted in the other complex cube root of unity. Same is the case अगर आप से squaring कर लेते हो second one, so at the end you will have the result in plus, means in this one. So hence it can be concluded here that each complex cube root of unity is the square of the other. Next property of cube root of unity is that product of 3 cube root of unity is 1. Product means multiplication. If you multiply these 3 cube roots of unity with each other, so as a result you will have 1. How? Let's prove it. Like this has been multiplied, 1 को आप multiply करेंगे, you will get the same. So these both brackets are multiplied. You can see here that there is just the difference of plus and minus, so you can apply a plus b and a minus b formula, like a square into b square, and 2 2's are 4 here. So you can see here that 2 and this is cancelled, and minus 3, so it has been simplified, and as a result we have got 1 here. So hence it is proved. It can be written in shortcut form as it is at 1 omega and omega square. Omega is this one and omega square is this one. So when this will be multiplied, omega into omega square into omega, it will result in omega cube, because when base are same, power can be added. So omega cube is equal 1. You have to remember this one. You can break up the power as you used to break the power of iota, like omega 4 can be written as omega 3 into omega. Okay. Next is that prove that the sum of all the cube roots of unity is 0. It means that if you will add all these 3 cube roots of unity, it will result in 0. Like 1 plus omega plus square will give 0. Let's add this 1 omega. The value of omega is minus 1 plus 3 minus 3 divided by 2, minus 1 minus 3 inside the radical divided by 2. Since here is addition sign in between these 3 terms, or we can say, so we can take the LCM here. 2 is taken as LCM, so here we have 2 and this is written as it is. This is minus 3, this has been cancelled, minus 2 plus 2 will result in 0. 0 divided by 2 will result in 0. So hence sum of the cube root of unity is equal to 0. Using these all properties, we will be given some we can say expressions in exercise 2.2, which we have to evaluate, which we have to solve, which we have to prove, and it will be inshallah done in our next session.